22.4 liters volume. Understood my point? N here is going to be what? Given volume by 22.4 liters volume. Any doubts? Just tell. Okay.
Mm.
So 22.4
No.
liters of O2 makes 1 mole, and that's what we are supposed to understand. Any doubts in this? Just tell. Okay. So what exactly does that mean? Similarly, if I give you calculate the number, I hope you have a calculator with you, present in 12 liters, present in 12 liters of ammonia gas. Can you calculate that? What is the method? Just tell me. What is the method? So this says calculate the number of moles present in 12 liters of ammonia. Understood my point? So I hope you're
Mm-hmm.
understanding how does it work. So it says calculate the number of moles present in 12 liters of ammonia gas. Even if it doesn't tell you it is a gas, ammonia, you have to going forward remember that ammonia by nature is gaseous. Ammonia by nature is gaseous. Okay. So you will say what? That by standards, what do you think will have? That 22.4 liters ammonia has or contains 1 mole. Are we understanding? 22.4 liters ammonia contains 1 mole. Are we understanding my point? So
Mm-hmm.
if 22.4 liters ammonia contains 1 mole, so 1 liter shall contain 1 liter ammonia contains 1 over 22.4 this much moles. Are we understanding?
Mm-hmm.
Got the point? The first statement has to be a standard statement. Got it? Second statement is going to be 1 liter of ammonia contains 1 over 22.4 moles. And then how do I make it into 12 moles? Into 12. So you get 12 liters ammonia contains 1 by 22.4 into 12. These many moles. Are we understanding my point?
Mm-hmm.
Got the point? Are we understanding or not? So 12 liters of ammonia contains
Mm-hmm.
1 by 22.4 into 12 moles. And how much is that value? So that's going to be 12 upon 22.4. So it's going to be 2 6 2 11.2. You get 2 3 and you get 2 5.6. So you get 3 over 5.6. Are we understanding? Any
Mm-hmm.
doubts in this? Just tell me. Okay, got the point. So whatever the value comes out, you can always calculate. So you get 30 over 56 because I removed the decimal. So I get 3 tens, 3 tens and then 3. Sorry, 2 15s. So it's going to be 215 and 228. So you basically get what? You get 15 over 28. These many moles of ammonia you will. Understood my point? Understood or not? Yes or no?
Yeah.
One more question. Now you will solve it. Calculate the moles present in. That's question one. Quickly calculate.
Mm-hmm. No, understood.
Now, can you calculate the moles for all of them?
Mm-hmm.
Will
Yeah.
it be easier for you, or should I solve it?
You have to do 16.7 divided by the MR of uh, calcium oxide. If I can find my calculator. Yeah. Okay. Um, okay, so the first question 16. White calcium is 14, oxygen is 0.298 molecules over not 18.7 6.8 times 10 to power. And 0.00311. And then for the last one, volume.
What is the answer? What did you do in the first part?
The first one
This one.
was 16.7 divided by 56,
Very good.
which is 0.2982.
Hmm. Then,
And the second one was 18.7 divided by 6.022,
hmm, that's it. What about 10 raised to power 20?
0.022. And then you have 10 raised to power 20 divided by 10 raised to power 23. So that's times 10 raised to power minus 3. So you get 0.00311.
All right. After solving all of it. Perfect. Right. Next.
And then for the last one I'm not sure how to go about it. But I think it's going to be like the same as mass.
No, look at the unit. The unit is liters.
Hmm.
When the unit is liters, what does that mean? When the unit is liters, it means what? That you have 5.6 liters of gas CO2. So when you have 5.6 liters of the gas CO2, so 22.4 liters we have what? We have 22.4 liters of gas. Yes or no?
Yeah.
So 1 mole, so 22.4 liters of any gas. And I hope you're understanding carbon dioxide is a gas. They will never tell you whether CO2 is a gas. How do I predict it? I should know what CO2's nature is. So then 22.4 liters is 1 mole because CO2 is a gas. So 1 liter will make 1 by 22.4 moles. So thereby 5.6 liters will make how many moles? It's going to be 1 over 22.4 into 5.6. Are we okay? So it becomes 1
Mm-hmm.
by 40. Okay. So
Mm-hmm.
that's the idea here. Any doubts in this? Yes or no?
Mm-hmm.
Next question. Now, always pay attention. The next type of question they can have, they will give you, that's the understand. Water is a liquid, yes or no?
Yeah.
It's a very important question now. Now, for any liquid, let's say you also understand that alcohol is a liquid. So for liquids, they want you to calculate the moles. Okay. But how do they do it? They'll say that we have 20 ml of water, calculate the moles. Now that's on the difficult side of the question, but it's not difficult if you understand the concept. It says 20 ml of water, calculate the moles. So you say that water is a liquid. So for liquid, we cannot 1 mole of liquid, the volume is 22.4 liters. No, you understand? For liquids, we do not apply this formula. We apply this formula only for gases. Are we understanding? We apply this formula only for gases. So when we apply this formula only for gases, what does that mean? Then when I say 20 ml of water we have, so you say that for water, always remember the density of water. For liquids, we have to go to the density. So what is the density of water? The density of water is 1 gram per milliliter. That means every milliliter of water weighs 1 gram. Are we understanding? Every milliliter of water weighs 1 gram. Are we understanding or not?
Yeah.
So when every milliliter of water weighs 1 gram, so I have 20 ml of water. Yes or no? By density, what do I know? By density, I know the mass per milliliter. For every 1 milliliter drop of water, the mass of water is 1 gram. If somebody's density is 2.5 grams per milliliter, what will you say? That if I take 1 ml of such a liquid, its mass would be 2.5 grams. Are we understanding this part, Aaron? Just
Yeah.
tell. Are we understanding this part? So 1 milliliters here is going to be 2.5 grams. Understood or not? Got it?
Mm-hmm.
So 1
Understood.
milliliter here is going to be 2.5 grams. So you understand that when we have this part here, so I'm going to say 20 ml would be 20 grams because I can clearly have an idea 1 gram for every ml. So for 20 ml, the volume is going to be 20 grams. Understood my point? Okay.
Yeah.
So we have this part. So 20 ml of water would be equal to 20 grams. Now you know the mass. And then when you know the mass of water, how do you calculate the moles from the mass? The given mass by the molecular mass. What is the molecular mass? 1 times 2 plus 16. And that's going to be 18. Are we understanding?
Mm-hmm.
So it's going to be 1 point. So 20 divided by 18. What is 20 divided by 18? You will have 20 divided by 18. Understood or not? You get the point or not?
Yeah.
So that's the answer. It's going to be how much? 1.09. These many moles. Are you understanding how to calculate the moles? But what
Yeah.
is important? You have to identify
Yeah.
the substance. If the substance is gaseous, identify the substance. If the substance is gaseous, okay? If the substance is gaseous, then what? What will you do? Tell me. If the substance is gaseous, then what will you do? Then you will apply 22.4 liters is 1 mole. If the substance is liquid and the volume liters or milliliters is given to you, then you apply the density formula. Okay. Now, let's suppose I give you this question. So I give you, I have 20 ml or 200 ml of alcohol. Pe2H5OH is an alcohol. whose exact name is ethanol. Okay. So 200 ml of ethanol I have. And the density of ethanol is 0.9 grams per milliliter. Question says calculate the moles of C2H5. Calculate the moles of C2H5. How do you calculate? How do you calculate? So what will you say? You will say that density is equals to mass upon volume. Yes or no? So what is the density given to me? 0.9. What is the mass? I have to calculate the mass because I know that ethanol is a liquid. Because it is a liquid, I cannot apply 1 mole is 22.4 liters. Are we understanding, Aaron? Yes or no? Okay.
Yeah.
Yeah. So what do you think we'll have? So we will have, this is the value. So mass upon volume. Volume is 200 ml. So I'm going to multiply. So this is going to be this much grams per milliliter. So you multiply here. So you get 0.9 into 200. And that's going to be my mass. So here, what is the value? This is going to be, that's going to be 180. This much grams is the mass. Are we understanding? So 180 grams here is the mass. Understood my point or not? Got the point? Okay. Yes or no?
Mm.
Now, once I know the mass, how do you calculate N? N is the number of moles. That's given mass upon molar mass. What is the molar mass? 12 times 2 because carbon mass is 12.
Right.
Hydrogen's mass is 1. 1 times
One
5
times
hydrogens
five.
here and 1 hydrogen is into 6. Oxygen mass is 16. So you get 24 plus 6 plus 16. You get 30 plus 16. So you get 46. So that's the 46 grams is the mass of 1 mole. So unitary method wise, if you go, you say 46 grams makes 46 grams of C2H5OH makes 1 mole. I hope you're understanding why is that. See, I can have 1 dozen apple and I can have 1 dozen pumpkin. Do you realize that 1 dozen pumpkin and 1 dozen apple both are 12 in number? But whose mass would be more? Whose mass would be more? Tell me. Tell me. Whose mass would be more? Apples are generally smaller in size and lighter in weight. Pumpkins are heavier. Yes or no? Are we understanding? So 1 dozen apple we have and 1 dozen pumpkin we have. Hello, Aaron? Are you there? Whose mass would be more, Aaron? 1 dozen pumpkin or 1 dozen apple?
Yeah, I'm here. I'm here. Yeah.
1 dozen pumpkin or 1 dozen apple? Whose mass would be more?
Neither. Wait, no. A dozen pumpkin and a
Obviously,
dozen
because
apple.
number wise they're same. So 1 mole would mean 6.022 into 10 raised to the power 23 of anything.
Wouldn't
You
be a
understand?
dozen pumpkin heavier? Like a dozen pumpkin would be heavier
Right.
because it's not going to be the same weight of the as the apple. You're not saying 100 kilos of pumpkin or 100 kilos of apple. You're in quantity.
You're not
So
understanding.
pumpkin would be
See,
heavier.
if I say 1 dozen apple, just answer my question. 1 dozen apple. It's not about being healthy. And if I say 1 dozen pumpkin, can I understand that number wise they're both equal 12 and 12?
Yeah.
But if I say apples are generally smaller in size, even if the heaviest of the apple on the earth would be lighter than the pumpkin, right? So if one apple weighs, let's say 1 kg, one pumpkin will definitely weigh 3 kg normally. So number wise,
Right.
they are same. But the mass of 1 dozen apple would thereby will be 12 kg. Here it is going to be 36
Mm-hmm.
kg. Are we understanding my point or not?
Mm-hmm.
So what does that mean? What does that mean? Just tell me. So we'll have 12 kg apple and we'll have 36 kg pumpkin. So that's the
Mm-hmm.
dozen mass. But the mass changes. Why? Because of their size. But does the number changes? Does the 1 dozen value change? No. What I'm trying to tell you is that if you take 1 mole of sodium and if you take 1 mole of CO2, if I look into them number wise, if I quantify them, and it's 6.022 into 10 raised to the power 23, and it is 6.022 into 10 raised to the power 23. Yes or no?
Yeah.
So the mass of sodium will be 23 grams and mass of CO2 would be 44 grams. That means masses change because of the size, because of the heaviness. But 1 mole remains the same. The number of particles remains the same. Yes or no?
Yes.
Got the point? So you have to understand it that. You have to understand it that way that when you have 1 mole of sodium and when you have 1 mole of CO2, okay, what does that mean? That you will have 1 mole of sodium and you will have 1 mole of this, the number of particles remains the same. What I'm trying to tell you is here that if you look at this question, why do I say 46 grams of C2H4OH makes 1 mole? Because there can be 1 mole of any substance, but the masses will change because their sizes change. So 46 grams of C2H5OH, 46 grams of C2H5OH, it makes 1 mole. So 1 gram will make 1 by 46 moles. So you have 180 grams. So basically 180 divided by 46 is going to give you the moles. Whatever is the answer. It's going to be 23 and it's going to be 90. So it's going to be 90 over 23. These many moles it is going to have. Understood my point or not? Just tell. Got the point. So it says calculate the moles of C2H5OH. Understood or got the point? Any doubts in this? Aaron, just tell me. Hello? Hello, Aaron. Are we understanding?
Yeah.
Yeah. So that's the idea we have. That it
Mm-hmm.
says calculate the moles of C2H5OH, and that's the answer we have. Understood?
Mm-hmm.
Okay. Now just get it. Now let's suppose we have what? Now let's suppose we have calculate. Now, next type of question. So do you get the liquid and the gas? If I tell you I have next question. Now the question will be something like that. The question says calculating the atoms within the molecule. Calculating atoms within the molecule. What does that mean? So when you have the atoms within the molecule, what does that mean? Just understand. So you have CO2. Now, if my question comes up that you have 1 molecule of CO2. So 1 molecule of CO2 means 1 molecule of CO2 would mean that it has 3 atoms of carbon and oxygen. Are we understanding? Got the
Yeah.
point. So when you have 1 molecule
Mm-hmm.
of CO2, it will have 3 atoms of carbon and oxygen. Got the point.
Mm-hmm.
Okay. Now, what does that mean? That means if I give you 22 grams of CO2, and I'm giving you the mass of the molecule. You understand this is a molecule. But I am after giving the mass of the molecule, I am asking you the number of atoms. I'm asking you the number of atoms. Now, how does it work? Number of atoms in 22 grams of CO2. That's what I'm asking. So I'm trying to ask you the number of atoms present in 22 grams of CO2. So when I'm trying to do that, what do you think this is the case? What will you say? What will you say? You have number of atoms in 22 grams of CO2. Okay. So what does that mean? Tell me. Got the point? Yes or no? So you will say that number of moles is equals to given mass upon the molecular mass, which is also equals to given particles upon standard particles with 6.022 into 10 raised to power 23, which is also equals to given volume over 22.4 liters if the volume is given to you in liters. Are we understanding? So this is the value of n. This is the value of n. So given mass over molecular mass is equals to given particles over 6.022 into 10 raised to power 23 is also equals to given volume by 22.4 liters. Are we understanding?
Yeah.
Right? So what does that mean? That simply means I am going to use this formula. Now, I am not supposed to calculate the moles in this question. I am supposed to calculate here the number of molecules in this mass. That means I am dealing with the number of particles here and the mass. And this question has got nothing to do with the moles. Okay, are we understanding this execution step? All right. Are we understanding this executional step? So how do I go about this? This question talks nothing about volume. Forget about it. This question talks nothing about the moles. Forget about that too. But this question talks about mass, and the question also talks about the number of atoms. But you tell me one thing. If I tell you I have one molecule of CO2, so can you say one molecule of CO2 contains three atoms in all? What do you mean by three atoms in all? What do you mean by three atoms in all? Three atoms in all means one atom of carbon and two atoms of oxygen. Are we understanding? One atom of carbon and two atoms of oxygen. Are you understanding?
Mm-hmm.
So one molecule of CO2 contains what? Three atoms in all. Now tell me, two molecules of CO2 will have thereby how many molecules? Two molecules of CO2 will thereby have three into two. Because if one molecule has three atoms, two molecules will
Yeah.
have six atoms. Can you tell me 10 such molecules of CO2 will have how many atoms in all? Tell me. 10 such atoms will have how many molecules in all?
Mm-hmm.
It's going to have 30. Are we understanding? Got the point?
Mm-hmm.
Any doubts on this? Then what do we have? Then what do we have? 100 molecules of CO2
Yeah.
will have how many? 3 into 100. That means 300 atoms. So if I have 1.57 into 10 raised to power 20 molecules of CO2, then it is going to be 3 into 1.57 into 10 raised to power 20 molecules of CO. Understood my point alone? Just tell me.
Yeah.
Okay. So the idea here is what? The idea here is what? The idea here is that when you have such things with you, right? So all you need to know to calculate the atoms, you need to know the number of molecules. Okay. So if you have these molecules with you, so first calculate the molecules. and then multiply that molecule's number into number of atoms present in one molecule.
Mm-hmm.
Are we understanding? Any doubts in this system?
No.
Got the point? So very
Yeah.
simple. Now, let's suppose if I give you this question, now have a look at this question. So in the previous question, I had given you 22 grams of CO2 and I wanted you to calculate the atoms in it. So 22 grams of CO2. And I wanted to do what? Calculate the number of atoms
Mm-hmm.
present in 22 grams of CO2. Present in 22 grams of CO2. That's what I wanted to do. So what will I say? Calculate the number of atoms present
Yeah.
in 22 grams of CO2. So what does that mean? Just tell me.
Mm-hmm.
Number of atoms present in 22 grams of CO2. So what will you say? You will say that N is equals to given. So first write down the standard formula. Given mass by molecular mass is equals to given particles divided by standard particles, which is going to be 6.022 into 10 raised by 23. Okay. Which is also equals to given volume by 22.4 liters. Once you do that, once you do that, you will have what? You will have what? Given mass is 22. Molecular mass of CO2 is what? Carbon's mass is 12. Oxygen's mass
12.
is 16. 16 times 2.
32.
So
44.
that's going to be 32 plus 12. That's going to
44.
be 44. What is the given particles? See, I am talking about CO2. So particles here would mean the molecules because I am actually given the mass of the molecules. The given particles is, I don't know, X. The standard particle is 6.022 into 10 raised to 26. Because this question does not talks about moles, I will not take moles. This question does not talk about volume, I will not talk about the volume. Are we understanding? So here I solve it
Mm-hmm.
1 over 2, and then 1 over 2 is nothing but what? X over 6.022 into 10 raised to power 23. So you multiply here, so you get what? 1 over 2 into 6.022 into 10 raised to power 23. Here is going to be equals to X. So you solve this, you get 3.011 into 10 raised to power 23. Here is going to be equals to X. Understood my point or not?
Yeah.
Yes or no? So that's the
Understood.
value of X. That's the value of X. Are we understanding?
Yeah.
Are we understanding or not?
Yeah.
Right? Now these are the molecules. That means I have 3.011 into 10 raised to the power 23 molecules of CO2. Are we understanding?
Mm-hmm.
Then what do we do? But I know for the fact that one molecule of CO2 has three atoms. So 3.011 into 10 raised to the power 23 molecules of CO2 has 3 into 3.011 into 10 raised to the power 23. Are we understanding or not?
Yeah. Mm-hmm.
Are we understanding?
Yeah.
So simple. What is there to calculate here? You are simply going to calculate the number of atoms present in the molecules. Are we understanding or not?
Mhm. Yeah.
Very simple. Very simple. Got it?
Mm-hmm.
Now calculate one more question. Now question says calculate the number of molecules So we have to apply two formulas simultaneously. What is the formula? Molecules present in 5.7 liters,
Mm-hmm.
5.6 liters of H2SO4 gas. Let's say I'm mentioning it as a gas. When I mention it, which is a gas, what does that mean? When you mention that it is a gas, what does that mean? Tell me. When it is 5.6 liters of a gas, what does that mean?
Don't you have to do by 22.4 liters
Right.
division?
So how do you calculate? You first write down the formula. It is given mass by molecular mass. Now first tell me, is this question talking about the molecular mass or it is talking about the volume?
It's talking about the number. It's talking about the volume,
Yeah. And what it is asking me to calculate?
number of molecules.
Yeah. So out of in this formula, we have four parts. And once we have four parts, what does that mean? Tell me. Once we have
We
four
have to
parts, what does that
we have to find given particles.
mean? This and this has to be equalized,
Mm-hmm.
and these two should be left as it is. So what do you
Shouldn't we
think?
find moles?
Given particles is X?
Wait. Shouldn't we find? Oh, never mind. Never mind. Never
See,
mind.
you can find number of moles and then you allocate it to this. So straight away calculate the answers. What you are saying that first I'll calculate the moles. Then I'll get the value of n. Then I'll equate it to this. Then I'll get the number of particles. What if I equate them straight away? Yes or no?
Yeah.
So given volume is what? 5.6 liters. And here the volume is going to 22.4. So it's going to be 5.6 liters divided by 22.4 liters. This cancels. So x upon 6.022 into 10 raised to the power 23. And that's going to be 1 over 4.
1.1055 times 10 to power 23.
Yeah. So the number of molecules is 6.022 into 10 raised to the power 23 divided by 4. So that's going to be 1.5.
1.5055. Because the
These many
20.
molecules we have together.
Yeah.
Understood my point? So if we have 1.5 into 10 raised to the power 23 particles, if we have 1.5 into 10 raised to the power 23 molecules in it, got the point?
Mm-hmm.
Got it? Now, but the question is, so that's the molecule. If I ask you the number of atoms present in it, now let's say it's the same question, I would have framed it that way. Also calculate the number of oxygen atoms present in 5.6 liters of H2SO4 gas. So you just calculate the number of atoms, the number of molecules, yes or no? In the previous question, the same question, you just calculated the number of molecules. Are we understanding or not?
Mm-hmm.
That came out to be 1.5 into 10 raised to the power 23 atoms. Uh,
Mm-hmm.
Molecules of H2SO4, yes or no?
Yeah.
Now you tell me, how many oxygen atoms do you think we'll have? 4. So one molecule of H2SO4 will have 4 oxygen atoms. So these many molecules of H2SO4 will have. So 1.5 into 10 raised to power 23 molecules of H2SO4 will have 4 into 1.5 into 10 raised to 23 because one molecule has 4 oxygen atoms specifically. So this time the question is not asking you the total number of atoms. The question is specifically pinpointing that how many oxygen atoms do you have in the particular molecule.
Mm-hmm.
Are we understanding?
Yeah.
Yes or no?
Mm-hmm.
So that's how you can. Understood?
Uh-huh.
Okay. Now calculate this question. Calculate this type. Calculate the number of atoms present in
Mm-hmm.
56 grams of HNO3. Can you calculate? Calculate the number of atoms of each type.
Yeah. Um, okay. 56 grams, including mass, HNO3, 1 plus 14 plus 48, 36, 0.88888 recurring, or 8 over 9 moles. Calculate the number of atoms of each type. Oh, the number of atoms in each type.
The first statement.
Okay, don't we have to find the number of particles?
Yeah.
Mhm. So you
They
do
will ask you to
56
calculate the
divided
atoms,
by
but there's a
63,
hidden step inside it. You will have to calculate the molecules first and then raise to the atoms.
6.002 times 10 to the power 23 is this. Answer times 9 over 8 is that. If this is the number of particles, then
So N here is going to be equals to what? Given mass by molecular mass.
yeah.
And that is equals to given particles by 6.022 to 10 raised to 23 is equals to given volume by 22.4 liters. Are we understanding my point or not?
Uh-huh. Wait, so if we have 56 grams, and then if that's our answer, if we do answer, number of atoms in the element is 5. Answer divided by 5, then so there's 1.07 particles of hydrogen, 1.07 times 10 to the power 23 uh, molecules of hydrogen, particles of hydrogen. And then there's the same for nitrogen. And then for oxygen, it's 3.212 times 10 to the power 23 particles of oxygen particles. That's what I thought.
Done?
Mm-hmm.
What have you done? Given mass is 56. What is the molecular mass of
Yeah.
HNO3?
Mm-hmm.
So that's 63 grams. So
Yeah.
given mass or molecular mass, that's 63. Given particles is what? X. Got it? So
Mm-hmm.
from here, you are actually calculating the number of molecules. So what does that mean? So it is 2 times 8. So it doesn't go by like that. It's basically 56 over 63. So number of molecules here comes out to be 56 over 63 into.
6.022 times 10 to the power 23.
Yes or
Yeah.
no?
Yes, I got 56 times 0.022 times.
Are we understanding the point or not?
Yeah.
Got the point? Solve this. So these many molecules you will have. Are we understanding?
Yeah.
Solve.
Mm-hmm. Then divided by 63. I got 5.352888889 times 10 to the power 23.
Perfect. So these many molecules of HNO3. Now the
5
question
point,
is
it's
telling.
5.35.
Okay,
5.352.
okay. 5.35. Now the question is asking me 5.35. Now the question is how many H atoms, how many N atoms, and how many O atoms. So from the molecule itself, I can see that there is one hydrogen atom, one nitrogen atom, and three oxygen atom.
1.071 times 10 to the power 23 for
Are we
hydrogen.
understanding? So we'll have one H, one N, and three O.
Already. Oh,
Got the point? So
yeah.
one molecule has one H atom. So these many molecules will have what? 5.35 into 10 raised to power 23 into 1. Got the point? N atoms will be. How many N atoms do you think we'll have? We'll have 5.35
No.
into 10 raised to power 23 into 1 because one molecule has one nitrogen atom. So these many molecules will have how many nitrogen atoms? From the molecule itself, I know that one molecule has three oxygen atoms. So these many molecules will have what? 3 into 5.35 into 10 raised to power 23 molecules. Are we understanding or not?
No, I don't get. Because that formula is for the number of uh,
That
molecules,
formula is for the number of particles we are talking about. We are talking about HNO3, which I can see is the molecules.
right? And there's five different, like there's five atoms in that one compound.
Exactly.
So
But the
shouldn't
question
we
says atoms
divide?
of each type. It's not asking you the total atoms. It is asking you to actually split it and tell me that how many atoms of nitrogen type, how many atoms of oxygen type, and how many atoms of hydrogen type.
Right, so shouldn't you divide by five?
Why should you divide by 5? Shouldn't you multiply? See, can you see from HNO3 molecule that one molecule has one H atom?
Yeah,
Can you also see that one HNO3 molecule has one nitrogen atom?
yeah,
And can you also see that one HNO3 molecule has three oxygen atoms?
yes.
So individually, can you not find? If you have an idea of one molecule, can you not extend it to the 5.35 into 10 to the 23 molecules? One
I
second.
I thought I thought you should divide it so that like at least in one thingy of HNO3, which has this many particles, how
Mhm.
many of them, how many of those particles are hydrogen, how many are nitrogen, how many are oxygen? You divide because that's the number of particles of like in 56 grams of HNO3. right? And then, so how many, in 56 grams of HNO3, how many particles are hydrogen, how many particles are nitrogen, how many particles oxygen? You
No.
divide by
Oh
5.
my God. No.
Oh,
Just have a look. Did you just calculate that you had in 56 grams of HNO3? You just calculated you have 5.35 into
mm-hmm,
10 raised by 23 molecules of HNO3. Are we understanding?
mm-hmm,
You
mm-hmm.
understand my point? So we have 5.35 into 10 raised by 23 molecules of HNO3. We have these many molecules. Are we understanding?
Yeah.
Yes or no? So I know these many molecules now, but my question says how many atoms of each type in all? So we will have some atoms of H type, some atoms of N type, some atoms of O type. You understand my point?
Yeah.
Got the point?
Mm-hmm.
So if you have 5.35 into 10 raised by 23, these many molecules if you have, you tell me.
Yeah.
So we have these many molecules of HNO3. So if I have these many molecules of HNO3, that means how many H atoms? So I know that one molecule of HNO3 will contain one H atom. So if I know for one molecule, how do I convert it to this? I multiply this with 5.35 into 10 raised to the power 23 molecules. Yes or no?
Mm-hmm.
So these many molecules of HNO3 will have 1 into 5.35 into 10 raised to the power 23 molecules, atoms of H. Are we understand?
Yeah.
So how do I multiply them? So I'm going to have 5.35 into 10 raised to the power 23 atoms of H. Understood or no?
Mm-hmm.
Okay, got the point.
Yeah.
Got the point or not?
Yes.
So that's the idea we have. Got it?
Mm-hmm.
So that's why I'm multiplying and I'm not dividing. You get it or not?
Mm-hmm.
Any doubts in this?
Yeah.
All right.
Yeah.
So that's the idea we have. Understood or not?
Mm-hmm.
Right. So that's the
Yeah.
idea we have. Okay. Next question. Solve one more. Now the question says calculate the particles or calculate the atoms present in 40 grams of CuO. Copper's mass is 63.5. Copper's mass is 63.5. Okay.
Mm.
So calculate the atoms present in 40 grams of CuO. Tell me. What does that mean?
Mm-hmm.
Tell me.
Yeah.
Tell me. Can you
Yeah.
calculate the number of
Yeah.
atoms present? Start doing it.
Number of atoms present in 46 grams of
In 40 grams of
CuO.
CuO. And I have already given you the molecule atomic mass of copper.
Okay. Mass over molar mass. So 63.5 plus 16, 40 divided by no, 6.022 times 10 to the power 23, 6.022 23 times 40 divided by 79.5. So 3.0299 is the total number of more atoms.
So what did you do? Given mass.
Uh,
So you first wrote the formula. N is equals to given mass
over molecular mass.
by molecular mass is
Yeah,
equals to given particles
over molecular. No, given particles over 6.022
over
times 10 to the power.
6.022 into 10 to the power 23 is
Yes.
equals to given volume divided by 22.4 liters.
Uh-huh.
Are we understanding? So given
Yeah.
mass here is what? 40. Molecular mass here is going to be what? 63.5 plus 16. So it's going to be 79.5. Are we understanding? So given mass by 79.5 is given particles divided by 6.022 into 10 raised to power 23. Are we understanding? Okay.
Yeah.
So that's the point we have. Understood? So if
Mm-hmm.
we have these particles, got it?
Yeah.
So what does that mean? So you are going to calculate the molecules we have. So we're going to have 40 over 79.5 into 6.022 into 10 raised to power 23. That is going to be x. Are we understanding?
Yeah.
So that's going to be x. So you calculate that value of x. So you calculate that value of x. Are we understanding?
Yeah.
Okay. That's the value of x. Now you solve it. So you're going to have whatever the value, you remove the point. So you get what? You get 400 over 795 into 6.022 into 10 raised to power 23. Here is going to be equals to x. Understood my point or not?
Mm-hmm.
Got it? So you're going to have 400 upon 795 into 6.022 into 10 raised to power 23. That's the value of x. Understood?
Yeah.
So solve, these are going to be the number of molecules. These are going to be the number of molecules, and that's going to be X. So it's going to be 6.022 into 10 raised to the power 23. That's going to be the number of molecules. Are we understanding?
Mm-hmm.
That's it.
Yeah.
Simple. So you have this. Now, number of atoms is one molecule has two atoms. So whatever is the answer, 400 over 795 into this is going to be what? Number of molecules. Understood my point or not? Yes or no?
Mm-hmm.
Okay. So that's the idea we have. That's the idea we have. Any doubts in this? Okay.
Yeah.
So you'll have 400 over 795 into 6.022 into 10 raised to the power 23. Got the point?
Mm-hmm.
So that's going to be the answer. Are we understanding?
Yeah.
So that's the basic idea. Got it?
Mm-hmm.
So that's the answer. So you multiply this with 2 and you get the number of atoms. Sure. Understood?
Mm. Yeah.
Yes or no?
Yes.
You get my point?
Mm-hmm.
Okay, now let's start.
Yeah.
Last topic, limiting range. Now have a look. So if you know how to calculate the moles, okay. Now, what is a
Mm.
limiting reagent? Understand. I hope the concept of calculating atoms within the molecules is okay for you, Aaron.
Yeah.
Perfect. So it says limiting reagent. What is limiting reagent? Just understand. Limiting reagent is basically what is limiting reagent? See. So limiting reagent basically is what? Limiting reagent is a reagent
Mm-hmm.
during a reaction which gets fully consumed.
Yeah.
Now you tell me, what do you like to eat the most? Tell me. What savory or what sweet do you like to eat the most? Tell me.
Savory.
That's got something to do with the concept. Tell me.
Savory.
Tell me. What do you like to eat the most?
Burger.
Is it a savory or is it a sweet
It's
or is
savory.
it?
It's savory.
It's a savory. What kind of savory do you like to eat? Name one savory.
Uh, burgers.
Burger. Perfect. So now let's take an example. So you like to eat burger. Burgers. Now, when you like to eat burger, so what exactly happens in a burger? I need the buns, I need cheese, I need onion, I need tomatoes. Yes or no? And I know that to make one burger, I need two buns, two half buns, right? And then I need one slice of cheese. I need two onions and I need four tomatoes. And obviously some other spices and other flavoring agents, right? Now, and some sauce. Let's say five TSP sauce. It could be a green sauce, it could be a red sauce, whatever you feel like you want to have that, right? And you have this burger. And you have this burger. Are we understanding? Now, when we
Mm-hmm.
are dealing with this burger thing, now understand. But now I have some guests coming over. So I got some, I ordered the raw material. I wanted to make some burgers at home. And I ordered these ingredients from the superstore or from the grocery store. Now, what I got is I got 10 buns. I got 20 cheese packets, 20 cheese slices. I got 8 onions. I got 10 tomatoes or 12 tomatoes. I got 60 TSP of sauce. Now, this is the ingredient amount of ingredients that I have. So, my question is that how many burgers effectively can you make? So, you understand that if you have two buns required, you have only 10 buns. So, if I just calculate the ratio with regards to the buns, by this ratio, I can make 5 buns if I count only the buns. That from 10 buns, I can make only 5 burgers. Are we understanding? Yes or no?
Mm.
Every burger requires one slice of cheese. So I have 20 slices. That means obviously this is sufficient. This is in sufficient quantity. Are we understanding? Because by then I can make 20 burgers if I just calculate with regards to the cheese. Because every slice, one burger. If I'm talking about two onions, what is two onions? What is two onion?
Two onions.
So two onions per burger. They are being utilized. And I have 8 such onions. So according to this ratio, if I look at only onions ratio, I am able to make 4 burgers. That means after 4 burgers we have made in all, the onions will be exhausted and onions will not be left with any more onions to really make the burgers. Are we understanding this part?
Yeah.
Similarly, I have 12 tomatoes, one apple, one burger requires 4 tomatoes. So I can make 3 burgers with it. And within 3 burgers, the tomatoes will be over. And one thing is important that to make a standard taste for the pizza or the burger, I need to have all the ingredients. You cannot skip any of the ingredients. And if I just individually look at the requirement of the sauce per burger, it will be 5 TSP per sauce. So if it is going to be 5 TSP per sauce, it would be able you're able to make 12 burgers. You're able to make 12 burgers. Are we understanding? So now you tell me that if I have only this much material, 10, 28, 12, 60, how many burgers can I make and I won't be able to make the further I won't be able to further make the burgers. I will be able to make only 3 burgers because then the tomatoes will be over. And then, no matter how much onion is left, no matter how much cheese is left, I will not be able to have that standard taste or the standard flavored burger that Aaron likes. Okay,
Mm-hmm.
what does that mean? What does that mean? Tell me.
Yeah.
What does that mean? Tell me. That means this tomatoes gets over first, and then the entire process of making burgers stops. Are we understanding? The entire process
Mm-hmm.
of making burgers stop. You understand? And when the entire
Mm-hmm.
process of making burgers stop, what does that mean? Tell me. When the entire process of making burgers stop, what does that mean? Tell me.
That means there'll be waste
There
of
will
the
be
ingredients.
exactly. So these reagents, these will be my excess reagents. These will be my excess reagents. And the other ones would be my limited limiting reagents. So the one which gets over the first is my limiting because that has limited the process, is my limiting reagent. Understood my point or not?
Mm-hmm.
Okay. So that's the point. So now you understand that if I give you an example of a limiting reagent, it's very simple. Okay. Now we need to understand one important part, and no matter where we go, no matter what kind of questions we solve, first of all, limiting reagent is applicable to only reactions. The concept of limiting reagent is applicable to reactants, to reactions. When I talk about reactions, I mean to say that it would have it would have what? It would have limiting reagents concept will be applicable to the reactions, right? So now if I say, let's say, so if I say A reacts with 3B to give me 5C plus 6D. Let's say if I give you this, are we understanding?
Yeah.
So if I'm giving you limiting reagents to this, so A plus 3B gives me 5C plus 6D, and like that. So, and I have given you what? So this is the equation. Now see, this is my standard recipe. So every reaction you understand that this reaction is nothing but just a recipe. It is nothing but what? It's a recipe. And if it's a recipe, what does that mean? If it's a recipe, what does that mean? That I know that if I have two atoms of A and three atoms of B, they will completely consume each other, and in the end, nothing will be left. Zero, zero A, zero B. You understand? Yes or no? So I'll be left with 2 moles of A and I'll be left with 3 moles of B. Nothing will be left. But do you realize that in reality, if somebody doesn't know the reaction proportion, what is the reaction proportion? The two particles of A reacts completely with three particles of B. That's the reaction proportion. Understanding? Two particles of A reacts completely with three particles of B. Are we understanding?
Mm-hmm.
So if I have two particles of A reacting completely with three particles of B, what does that mean? Tell me. What does that mean? That if I have 200 molecules of A and 800 molecules of B, now my question is which is the limiting reagent? So I would be given the moles. I would be given the moles. So I will have 200 moles of A and 800 moles of B. And the question says calculate or find, calculate the limiting reagent, calculate the
The
limiting
limiting
reagent,
reagent is
and
the
also
one
calculate the
in
excess
A.
reagent. Are we understanding? So question says calculate the limiting reagent and also calculate the excess reagent. Understood my point or not?
Yeah.
So what does that mean? What does that mean? So when you're talking about A, so what do? You are given the moles. So this is the moles that the normal person takes without knowing the equation's proportion. Are we understanding?
Yeah.
Got the point? So we're going to have 200 divided by 2. So what do? The given moles that we have, I am going to divide the given number of moles with my stoichiometric coefficient of the equation, which is 2. The stoichiometric coefficient of A. And the stoichiometric coefficient of A is what? What is the stoichiometric coefficient of A? Tell me. That's 2.
Yeah.
What is the stoichiometric coefficient of B? That's 3. Are we understanding?
Mm-hmm.
So that's what we know as the value. So what do we do? 200 divided by 2. 200 divided by 2. Understood my point or not? Are we understanding?
Mm-hmm.
And here what do we have? Here we'll have
Mm-hmm.
800 divided with 3. Here we'll have 800 divided with 3. Got the point. Got it. So we'll have 800
Yeah.
divided with 3. So when you have 800 divided by 3 and you have 200 divided by 2, so here it is going to be 100 and it is going to be 800 divided by 3. So whose value comes out to be smallest? 200 by 2 is 100. 800 by 3 somewhere around 266 point something.
Mm-hmm.
Which is a smaller value? Tell me, which is a smaller value? 200 by 2 or 800 by 3?
200 by 2.
Yeah. So that's what it is. So the question will give you moles. You divide those given moles with the stoichiometric coefficients, and whatever the value comes out to be smaller is the limiting region. That means in out of both A and B taken, A will be completed or A will be finished first. And because A gets finished first, what does that mean? Tell me. Because A gets finished first, what does that mean?
Is the limiting reagent.
That's my limiting region. So this is one of the simplest questions. So the other part would be this is going to be my excess agent. The other one is going to be what? Is going to be my excess reagent. Are we understanding or not?
Yeah.
Right? So this is one of the simplest questions that possibly I can discuss with you. The remaining ones we'll discuss tomorrow. Primarily, I might connect with you tomorrow sharp at 6 in the evening. So 6 in the evening here for you would mean 4 in the evening for you, I think, approximately.
3:30.
Okay, 3:30. So I think that's a suitable time because it's Sunday. It might be an off in school.
Yeah.
Okay, so we'll connect and we'll discuss limiting regions, and I think you'll be done with it. But I hope all the topics we have been able to cover up: the empirical formula, the limiting region, the
Yeah.
percentage composition. So revise them. We'll discuss all the questions, and we'll keep a 2 hours class tomorrow to cope up with the syllabus thoroughly. Okay.
Okay.
All right. So just go type by type, Aaron. First, how to calculate the moles. Second, to calculate the particles in that, and then we'll discuss the questions. Okay.
Okay.
All right. Thank you. Bye. Best of
Bye.
luck.